Hello, good morning, everyone, and thank you for joining Manifest Cyber and Arthur AI today for an exciting, riveting discussion all about the impact that AI coding is having on enterprise AI governance. Hopefully, by the end of this webinar, you'll walk away with three things. The first is a clear picture of where enterprise AI governance is actually breaking down today. Second, framework for thinking about build time versus runtime enforcement. Might be a little bit of a spicy topic today. And lastly, and perhaps most importantly, some practical steps you and your team can take to close the gap between AI adoption and AI oversight. We'll have some time at the end of the webinar for live Q&A, so feel free to start thinking about your questions and saving them for them. So to set the stage a little bit before I introduce myself and my illustrious co-host here, it's no secret that AI security and AI governance are hot topics, right? I'd say you'd be hard pressed not to find someone talking about this on the interwebs or across LinkedIn. But at this point, they're so broad, they've almost lost their meaning. So what I keep coming back to is that the hardest part of enterprise AI governance right now isn't that people don't care about it, right? Everyone is talking about some aspect of it, but it's about that the tools have gotten so far ahead of the controls, right? All gas and no brakes. No code and low code platforms have made it trivially easy for any employee in the enterprise to build and deploy an application, including C-suites like myself and Zach. So even your leadership are creating shadow AI. And while that can be genuinely useful, it's also genuinely dangerous or concerning for the security team. And when a random person in the enterprise built an AI app, like they're not always thinking about where the model came from or what data it was trained on or how they trust it or how do they tell someone what agent they're using or where it's being deployed? They're just thinking about solving a problem. That's their job. And governance is supposed to be the guardrail, but it's not there. And if we're really going to think about securing enterprise AI at scale, we really have to think about how to do this in an automated way. So Zach and I are going to chat deeply about this today. Two places specifically where the gap shows up the most. At build time, when applications and models are being assembled, and at runtime when they're actually in production doing things that are hopefully helpful for the business, but that few of us still may not understand how it's doing what it's doing. They're not the same problem and they don't have the same solution. So excited to welcome Zach here. Zach, why don't you start off with a little bit of an introduction on who you are and Arthur AI, and then I can follow up.
Yeah, absolutely. Thanks, Dan. So, more than happy to be here. I'm Zach. I'm the CTO at Arthur. We are an AI observability and governance platform. Been around for 6 years now, 7 years, and got our start in the traditional machine learning space. Then, like everybody else in the world, around 2022, pivoted into generative AI, and now think holistically about what does it take to invest in AI for a large enterprise, and how do people who are building these systems do it in a way where these things actually work, they have confidence that they actually work, and as they deploy it, they are sure that they are meeting whatever controls and or requirements they need to that are specified by regulatory and or sort of compliance frameworks. So yeah, great, happy to be here. We're gonna have a great conversation today.
Awesome. Love the mention of the pivot into generative AI governance. We not necessarily the pivot, but also added that to our story. So on that note, I'm Daniel Bardenstein, CEO and co-founder of Manifest Cyber. We are a software and AI supply chain security startup. We focus on the question of what's in the software and AI that organizations are building and buying. And to the point today, we're very interested in not just knowing where AI is, but how it was built, how do you trust it, how did it work, how is it assembled, and other risks upstream. So excited to have you here, Zach, as we're going to talk about this problem from a couple different angles, maybe have some spicy takes, and hopefully this also reflects a conversation that's happening in terms of where to prioritize people and dollars across various enterprises around the world. So let's jump in. So first, let's talk about what can go wrong. AI security, AI risks aren't necessarily this theoretical thing. We're seeing the risk happening every single day, and I'll share a couple of fun anecdotes and observations that we've seen, and Zach, by all means, jump in and share what you've seen. for us thinking about supply chains and where you trust AI, it's one thing if you're just using, Claude Code and you're just hitting Anthropic's API, kind of boils down more to the question of do you trust Anthropic or not? But we, with our customers, continue to see, poisoned packages upstream, models trained on problematic data sets, questionable or problematic models just ever so slightly fine-tuned so that people can give them a new name and version and kind of hide their lineage. Basically, like what we're seeing with Team PCP and open source packages in terms of supply chain attacks, but that sort of risk for AI already, both from the model and the data set side. And once organizations suck this stuff into their environment, whether someone's messing around or downloads a model from Hugging Face, the risk is already inside. What does this look like to you, Zach? What are you guys seeing?
Yeah, absolutely. I think what's really interesting here is, over the last 40 years as software has developed, and, we've seen sort of the SaaSification of, software services. The foundations upon which software has been built, hasn't necessarily been designed with security in mind. So you see lots of problems, with supply chain attacks, with, security vulnerabilities and the operational toil that goes into managing like CVEs and things like that. And thankfully, we've to a degree have been saved from a lot of these problems because the limiting factor in writing the software and maintaining the software was human attention and time, right? So, the ability to produce software has been significantly bottlenecked. The biggest bottleneck here is just engineering time and engineering focus. But with the adoption and rollout of these AI assistants that can now write code, debug code, deploy code, they're doing this at the speed, 100,000 times faster than what we've seen previously. And not only that, but these tools are now accessible to a much larger audience. And so, what this has really done is taken a problem that's existed that, has been sort of solved by, a security through layer kind of approach where the attention was the limiting factor and really poured gasoline on this fire in a way that we're starting to see the sort of the same class of problems, maybe different manifestations, obviously different tool chains, different frameworks, different services, but similar class of problems. But now we're seeing the sort of the scope and the magnitude of these problems just increase significantly. So it's a very interesting time to be doing this, and is obviously an ongoing problem. We're going to be talking a little bit about what the solutions in this space look like today.
Yeah, I think the scale, we're seeing similar stuff, and it's interesting. There are a lot of parallels, right? There's a whole, I don't know if it's still as spicy as it used to be, but discussion around, AI is a subset of software. So a lot of the problems we're seeing with software are appearing with AI. But there's just extra element of the speed and the scale and the opacity of AI that's making all this stuff worse.
Yeah.
So on that, let's dive in a little bit more. Zach, talk to us a little bit about some of the gaps, like on the building side, when people are actually starting to incorporate AI into their internal applications.
Yeah, absolutely. I could touch a little bit on this, but maybe generalizing this across a framework, right? So we take a look at how these AI tools are entering into the organization, how they're impacting the organizational structure, the way in which we do work. Obviously, one of the biggest ones here is that you're seeing non-technical users who have never interacted with a single line of code in their entire life, building completely end-to-end applications that are driving very real work in the business. And the impact that that has, obviously, to the security, governance function, but even on the IT function as well, right? Like these things have to be deployed, they have to meet requirements. And there's a big gap here in terms of the organization's ability to handle the same type of process, but now you have to do 10 to 100x more of these requests. Similarly, these agents as they're being deployed, as they're being built, they are, they need access to systems in the same way that existing software, existing personnel need access to systems. But the sort of the confounding factor here is that these agents are operating in ways that humans have never really operated before, where they might be, reaching out to things that the agent has determined, hey, in order for me to accomplish this task, I need access to this other system. And they're doing that at lightning speed. So these applications are touching real things. And in many cases, the enterprises we're seeing, the most valuable use cases are the ones that are touching the most sensitive data. So, you have to really think through what access control, what identity management, what securing these things looks like, right? As Daniel is going to talk a little bit about as well, and I'm sure he can kind of weigh in on this one. But in the same way that you're managing dependencies in software, you have to manage these dependencies in your models that you're choosing. And so as you're thinking about selecting like which are the models that I want to be using for this application, you have to be really thinking through the threat vectors of what happens if this model has a vulnerability that's disclosed, or most recently, probably everybody in this room is aware of, with Fable and Anthropic, like what happens if this model doesn't become available because of some geopolitical thing, right? And then finally, you kind of take all of this, you combine this, you have an enterprise that wants to be really forward leaning, is investing in AI, is getting ahead of this. But these services, these applications are entering the business in a way that can happen completely invisibly. So we're going to talk a little bit about how the shadow AI problem is a little bit different than what traditional software development looks like, and how you sort of think about putting this boundary around your enterprise so that you can identify and understand what this like shadow AI footprint is and what it's doing.
Yeah, I'd love to jump in a little bit on that shadow AI aspect. So, we did some research last year. We talked with, surveyed several hundred AI and security practitioners around the world. To no one's surprise, AI adoption very high, very fast. But the lack of visibility, we thought was coming, but we're surprised to the degree of it. The shadow AI problem, to me, it always sounds a little bit marketing-y. You take two buzzwords, kind of smush them together, but the prevalence and the deepness of the problem, can't be understated. The ease with which people can just download tools like Cursor or Windsurf that are AI enabled, or people can just download models from Hugging Face. One anecdote on this that we've seen and is kind of mind-blowing to me is there are organizations that have just blocked access to Hugging Face, period. Right? So no one can actually download open weight models or public data sets, which is crazy because they don't do that with GitHub or open source package managers that can have the same amount of risk. But just it goes to show not only the ease with which people can download AI-enabled tooling, but the difficulty and the lack of AI governance such that the way that these security leaders have determined is the most effective way to stem the risk is to just block, which, as we all know, isn't a good and valid long-term strategy and can also be subverted quite easily. And you mentioned this too, Zach, which I find myself shouting from the rooftops as well. AI doesn't live in a vacuum. Like all these models, they're built with software, they ship in software. Again, we're all about supply chains. We have seen, for example, in some of the AI-enabled IDEs that people love to download and then start, typing prompts into to build code, they ship with exploitable vulnerabilities. So enterprise users are just literally downloading vulnerable software to their desktops, which is absolutely nuts to me. But I guess that is just how software works these days. And on maybe a little bit more, lesser known point, another thing that we've seen a lot in terms of risk that can actually really bite enterprises, less on the traditional vulnerability side, but on the less sexy, but very daunting legal and intellectual property risk side. Most people are probably familiar with traditional software licenses, right? You've got your strong copyleft licenses, which are bad to use for open source. You've got your permissive licenses like Apache 2 and MIT. That means you're in the clear to use open source software in your applications. Not all AI and models and data sets specifically fall under those categories. And so we've seen cases where organizations attempt to use models and data sets that are for use cases that are actually prohibited by the supplier of those models or data sets. So they're actually violating the legal terms of that model and obviously putting themselves at risk, both from potential legal action, but also they have to then rip out whatever they were using and rebuild. Even things like I love to kind of poke at the Meta Llama models, which I think are a little bit lost their sheen from when they were first launched. But you couldn't use a lot of those early Llama models for a lot, right? You couldn't use them for anything related to, sure, military warfare, nuclear stuff, but even critical infrastructure, transportation, or heavy machinery, right? So like really narrow use cases. And as we all think about, security and vulnerabilities is important, but I remember talking to security leadership from a Fortune 500 company who said the only thing their CEO cares about when it comes to selecting AI was whether or not it was legal to do so. And aside from the legal side risks, yeah, talk to us a little bit about shadow agents across enterprises.
Yeah, absolutely. So, in our conversations we're having with enterprise leaders across the security function, the information function, the engineering function, the feedback we're getting is consistent and coherent. There are way too many applications that are entering into their business that are using AI. And so, in our experience in these conversations, we've broadly categorized them into four different categories. So you have applications that your engineers are building internally. These are the agents that you're building. You're deploying them into your cloud services, whatever. You have applications that your business has been using probably for 10, 20 years. Think Salesforce, Slack, Google, right? These applications are all also starting to build AI native software that is bringing very real regulatory and compliance risk that you have to audit and assure and sense. Um, then you have the personal AI assistants. These are Claude Desktop, OpenClaw, Hermes, whatever the agent frameworks that people are using. It has never been easier to really quickly spin something up, give it access to a bunch of stuff, and then kind of hope that it doesn't do anything bad. And then finally, you have sort of the AI native companies that are coming in, that are sort of like new offerings similar to the software that you've already been using, but really doing a lot more in a way of leaning into those AI services. So, there's a lot of a very broad range of how these applications are getting into the ecosystem. And so, if we go to the next slide here, really what this looks like, is you have all of these incoming applications, and there's a big and deep desire, a very real threat for organizations to need to adopt AI, because the financials, the execution for a lot of these companies that are venture backed that are entering into the market today, the reality of the situation is you can do the same amount of work and provide the same offering with a quarter of the headcount and half of the budget that these incumbent companies have. And so, the idea here is that, like, over time, we're going to see an explosion of these agents entering into the enterprise. And this here, Gartner basically predicts that, it's going to be an exponential curve. The trend's going to go through at least 2028. I think we're going to see a similar thing as we saw with the cloud transformation or digital transformation.
So, Zach, let me ask you a question that I'm curious to get your take on. Every enterprise tool out there is now boasting about and building agents, right? Like you said, Salesforce has agents, ServiceNow has agents. How important is it that organizations understand all the specific agents and their operations and trust and security in their third-party tech? Like, do I need to trust or know about all the Salesforce agents and ServiceNow agents that are doing whatever they're doing?
Yeah, the answer is yes, absolutely. It's extremely critical. I can give you a couple of different examples. On one dimension, we have regulatory frameworks that are developing. So the EU AI Act, for example, is going into effect or starting to go into effect in August, and it immediately creates risk for international companies that are operating in Europe if you cannot, basically define how you are using AI, particularly in situations where it is making decisions that impact some end user. You need to be able to source, your AI bill of materials. You need to be able to justify the algorithm. You need to be able to have auditable records on how you're training these things, how you're assessing, how you're evaluating those models. So it's a very critical thing. Obviously, the United States is working through legislation. They're moving a little bit slower by design, but the sentiment and the trend is clear, right? Like these are very critical systems that are going to be relied on much more regularly and are going to be regulated. And so the work that you need to put into place today is how do you maintain visibility over how these systems are working so that you can address those regulatory concerns.
Awesome. Yeah, it's a tall order, but I
Yeah.
think about this as well as we start to build and our customers start to use third party agents. Just more things to worry about and having to understand.
Absolutely. And to, the second way in which it's relevant is sort of captured in the slide here, which is The way you think about managing access and within your organization is completely different now, right? So agents are operating at a much faster scale, and there's going to be a lot more of them. And the idea is, the way that most organizations have been managing access to systems, once again, has been bottlenecked or limited by people focus and attention, and that doesn't work with agents. So in order to think about how do we autonomously serve these requests in an agentic setting, these agents require access to different tools across different interactions. They're non-deterministic. So they might be accessing Salesforce, they might be accessing Google, they might be accessing, other systems differently across multiple different interactions. And these requests need to be actioned in machine time, not in human time. The agent will time out on a response if you don't get access to those systems correctly, and then, basically provide zero value. Both of these things combined lead to orders of magnitude increases to your IM systems, which is going to overwhelm your IT admins. And these agents are being deployed in a way that bring very real security risks that are unsolved to an organization. So how do you think about PII detection and masking? How do you think about prompt injection and preventing secret leakage and token leakage and things like that? So it's really, you have to have an answer for these things, even if you're bringing in a third party system, because that third party system is likely, if it's doing anything valuable, interacting with other systems in your organization that also carries this risk. So it's extremely critical to be thinking about how you're thinking about, to be thinking about, how you're securing these systems, how you're observing these systems, what kind of safeguards you have in place to make sure that these things are doing what they're supposed to be doing.
Yeah, I mean, agents are basically almost functioning like humans, right? They're like little
Yeah.
identities that are running around that have access to tools. They just operate. They take action non-deterministically and not necessarily predictably, and they don't have necessarily all of the monitoring and logging and enforcement that like a traditional user account would have. Is that fair?
Yeah, that's right. And the traditional like security reviews don't work here, I think. Typically the SOC 2 or the ISO standards, you ask for some documentation, you might read it over, you might ask them for, some certification, but when you're talking about agents, the non-deterministic factor here, I think just is really challenging to break. And so, on the next slide here, basically our belief at Arthur is you can't govern what you cannot see. And, we'll get into a little bit more of this, Dan, later down the line. But, there's this concept of like, how do you think about, governing these systems? And it's our belief that, with all of these novel threats, with all of these novel ways that these systems are entering into your enterprise, you have to be able to observe these things and how they're running. And if you're not doing that, you're carrying risk.
We often use the same exact messaging, and I think it's something that a lot of people understand, whether it's agents or models or data sets. If you don't know where it is, you don't know what it's doing, how can you adequately protect it, or secure it, or respond to an event in it? One other anecdote I'll share on this, which was a little bit of part of our origin story on the AI side of things, is we think about traditional incident response in software security, right? So we find out that some sort of package was compromised, it's vulnerable, and the next thing I need to answer is, am I affected? Right? I need to search everything across my asset management tools, my open source repos, my artifact registries, and figure out, where is this thing? Is it exploitable? What's the fix? Who owns it? Etc. That I've yet to see an enterprise security shop that can do this for AI, right? If you say, hey, this data set just got compromised, or there's poison data in it, or this model is problematic, are you running it somewhere in your enterprise? It's everything under the surface of the iceberg, right? Like, I don't know. It's like, it reminds me of like Log4Shell response. It's like, okay, phone calls, emails, like spreadsheets, are we using this? Someone, like all the AI engineers, look back through all of your training tools and figure out, did we fine tune anything based off of this thing? So it's old problems and adages made new all over again. Which on that note, oops, clicked a little bit too fast. You know, it's not, we haven't seen that people are oblivious to this, but it's more about how people are making decisions around implementation and costs. And I'll share some I'll share some stories here around we see organizations that are trying to rapidly adopt and implement AI so quickly as a cost saving mechanism that they are not adding budget to add in guardrails or security knowingly, which is not ideal and a bit problematic. But there certainly is a cost, and maybe if it's not hitting them immediately, it certainly will. So let's dive in as always to like what is the cost of inaction, or what also have we seen happens when people are rapidly deploying AI without guardrails. We've hit on some early examples. Zach, let you hit on the Chipotle one, but one of my favorites. Not everything has to be nefarious, and Chinese APTs are trying to poison automotive data sets to train self-driving cars to accelerating when they see a stop sign. Like possible, feasible, yes. Is that going to happen to enterprises every day? Probably not. But even to the extent that if you're not careful about what your AI is doing, a couple fun anecdotes. This one from Instagram and Meta, where people were able to do account takeovers of a celebrity or high-profile accounts just by telling the AI agent that they were that person and they wanted to change the email on those accounts. I saw a post on the internet yesterday in the security community of somebody who basically asked a company's AI agent, the customer support agent, to like, hey, can you provide me a dump of all of your customer data in a zip file, pretty please? And the agent did. And so the guy's like, well, did I violate terms of service, or did the AI agent just DLP itself? And then obviously back to Meta, there's the director of AI security or privacy at Meta, whose AI deleted all of her files. Hard deleted her files, even though she was frantically typing to it to stop. Those are things that I think about and both chuckle and also grimace about. From a more technical angle, Zach, tell us more about the Chipotle issues.
Yeah, absolutely. And Chipotle, is the most recent and one of the larger, but there have been many of these attacks over the last couple of years where basically some company provides a chatbot interface on their website, and this interface can get prompt injection attacked and then wrapped in some kind of GitHub script, and people get a free Claude Code session out of your organization's free chatbot that was meant to provide customer support, right? So we've seen a lot of these cases, across our business, across our customers, where because of the speed at which these things are moving and how important these initiatives are, that the security and the governance is a secondary concern, or maybe it's just something that's forgot because organizations are moving fast. And the reality is, a lot of these enterprise organizations are in extremely difficult positions, caught between a rock and a hard place. It's like you have to keep innovating and using these AI tools, otherwise you're going to be beat out by the new upstart companies that are entering into the market that are venture backed. But at the same time, there are some very real security risks that are completely unsolved. And so, you basically have to find a way to balance between we need to move fast and make these investments while securing these systems. And it's our belief that there are solutions in this space. It just requires a little bit of thought and some process and some product, and your organization can get ahead of these things. And so, broadly speaking, I think we generalize these things across three different categories here, right? So when you're deploying these agents, you think about, what is the financial risk? So a lot of headline, a lot of news here recently. Uber obviously was a big one. Microsoft ripped out Claude Code from their organization. Uber, for example, blew through their entire AI budget in 4 months for the year. So there's big financial risk if you're not paying attention. Same security compliance risk. We've been talking about DLP, the prompt injection. Those things are unsolved, and very difficult to get right, but it is possible if you really think through and align on your policies and process. And the same with operational risk here, right? Where it's the idea that your agents might be giving you wrong answers. Another great anecdote here, a couple of years ago, Air Canada, had an agent that was online that told a customer that they were allowed to have a refund, but it was against their policy. But it was taken to court, and the consumer won because the AI agent was basically representing the company in that setting. So, not having sort of the safeguards in place here to check for correctness or groundedness, or is the agent performing the right operation, can carry some pretty significant risk to your business.
It really seems like this is a great time to red team any AI agent that one finds on the internet, right? Anytime you find a some sort of agentic chatbot or something, you might as well ask for a refund, ask for customer data, ask for, whatever, apostrophe, drop all tables. It just seems like a great time to have some fun. Not that I am, condoning this or suggesting anybody go and do this, but um, really illustrates that the tax that consequence of rolling this stuff out so quickly for efficiencies without thinking about the guardrails in ways that hopefully give us a little bit of a chuckle and maybe a little bit of heartburn to the developers, but in a way that is recoverable.
That's right. Yeah, it's a Schadenfreude, right? Like we can appreciate, how interesting and engaging this is being in the market, but I would hate to be one of those Chipotle engineers.
Yeah, it sounds like someone should make like a Schadenfreude.ai or something where it just lists all the funny stories that happens with silly prompts, especially some of the frontier models and the early answering of various questions. But maybe a side project for someone on the call or for one of us in the future. All right, so we've talked a lot about the problems, right? Racing to deploy AI without guardrails. What are some actual risks? How that can manifest in terms of security risk, financial risk, operational risk. Obviously, we got to leave people with some semblance of what good looks like and what people can actually do and take home to their companies to actually implement. So let's start in there. For us, we've seen some good, we've seen some really bad, and obviously we won't name any names here. But for a couple of key questions that we find people orienting their AI governance around, understanding who built what and how. Right? Again, just like traditional software, if there's a software component somewhere in my enterprise, I want to understand: did we build it? Did a supplier build it? What security protocols, processes, scans have we done against it? Where is it deployed? Who owns it? What's the patch cadence, etc. All that stuff is really important. And I know we'll talk about open weight models in a second. I saw there was a question about it in chat. This is where AI can slip in very quickly without having those questions. Like if we see a model somewhere, do we know who owns it? Where did it come from? Did someone just take it carte blanche off of Hugging Face, or did they fine tune it or secure it a little bit, right? And also, who's just responsible for it? Also, really, really important from the models all the way down to the data sets and the tuning, and especially if it's a custom model. Second, one thing we've talked about pretty significantly, which again sounds so simple, but we still continue to see organizations not investing or doing this in a first class way, is basic inventory, an updated inventory of what AI systems or components do enterprises have and where? What models do we have? Where are they deployed? What data sets do we have internally, or what are public facing data set, like publicly available data sets we've brought in to tune models? If we have derived or fine tuned or otherwise customized models, where did those things come from? What's the story? How to go from the base model to some fine tuning to quantization, distillation to some customized model, and then where is that? Understanding making sure we know the provenance, the licensing, the lineage of all of those things is super important, just like we would with any other piece of software. And then as you've been talking about, Zach, like level of access, right? Knowing what AI and especially agents or MCPs have access to, right? It's one thing if it's limited scope. If you have Cloud Code or some agent that has access to all of your critical systems, that's certainly a big source of risk that organizations need to be thinking about in terms of, again, policy enforcement and response. What's your take here, Zach? Where would you like to add?
Yeah, so I'd actually, controversial, I know, maybe a hot take, right? But I think we think about things a little bit differently, right? And the way that we like to think about things is if you're only looking at supply side, then you're still a victim to the process. And what I mean by that is it's always possible for somebody to bypass whatever the requirements or the controls are and bring something into the organization that didn't go through the official process. Now, whether that's a developer that's going rogue, an inside threat actor, or even like we were talking about, hey, we're executives that are now enabled to actually build and deploy systems. And so we can, by design, I think, kind of bypass a lot of the things to do something important. And so it's our belief that if you actually, want to govern and ensure that you have that boundary, you need to do it at the runtime. And there's no other way to ensure that you are really observing and controlling for all of those ways in which AI can get introduced into your business, which I know is kind of a hot take, Dan,
Yeah,
because
I mean,
yeah,
I see the point. I'll push back a little bit on that because we've seen a lot of instances where people like, yes, runtime, not understanding what any system is doing is important, but it's pound per pound more effective and slower to implement mitigations or patches or other sort of uh, uh, you know uh, protective steps or yeah, mitigations to a system that's already been running versus earlier in the design phase, especially if it's something that a company is building in house. So if I'm just taking something random off the internet, if I'm just taking OpenClaw and throwing it out to the wind, like sure I can run protections around OpenClaw, but if there's inherent vulnerabilities, if it's not really built secure by design, secure by default, I'm gonna end up spending more time, more cost trying to bolt on logging and security practices afterwards. So we there's definitely a lot of this the runtime build time discussion we see out there as well. We find that like a lot of the emphasis seems to be on runtime, all good and important. People shouldn't be forgetting about build time, and we'll talk about open weight models a little bit more because that is a great vector for supply chain attacks, especially as we're seeing with all the team PCP attacks in open source where they're compromising developer workstations and developer credentials. If the pipeline is no one's looking at the pipeline and just whatever gets pushed out, we trust, we know how it works. It's adversaries always target opacity. But when we move to what this might look like, if we go more on the runtime side a little bit in terms of putting this into practice and automating a little bit of this, see if you can convince me here.
I think you might have skipped one if you go. Oh, maybe not. Okay. Yeah. So I'd say a real solution here, like if you want to do the best, you're going to need both, right? So I will acknowledge that, but I'd say again our approach here is you have to be able to measure and see what you're governing. And the approach that we take here is sort of a three-staged approach. The first thing it starts with is discovery. Can you put that boundary around your shadow AI, around your organization, and identify things that are currently not under governance? Once you have that boundary, now it's about observing what those agents are doing. What interactions are they taking? What tools are they using? What data systems are they accessing? And then once you have that observability in place, you can now start applying real governance and enforcing policies on top of how these things are acting. And that can drive, enforcement and control workflows. That can drive alerting and notification workflows. And this sort of like three-stage process gives you complete confidence that you have that boundary around your enterprise. Everything that gets brought in, no matter which vector it's brought in under, is going to be governed through your organization's policies.
Fair enough. Certainly something people have to think about. Hard to push back on there. Discovery is an interesting thing, whether you discover after something has been built and deployed, or as we tend to think about it, trying to understand discovery like as it's being deployed, or even again
Yeah.
as things are being built. As we mentioned, when we think of things in terms of supply chains and their build pipelines, which for us looks a little bit like this, right? Someone mentioned open weight models in the chat. These days, sure, if you want to use frontier models, a lot of people still are. We're continuing to see increased reliance on open weight models because they are cheaper and lighter weight, and you can put them wherever you need. but it starts with someone else's stuff, right? I'm starting with someone else's model. I'm putting it in some sort of Python notebook. I'm probably just going to throw some data sets at it. Load some data sets in my Jupyter notebook or Databricks or whatnot. Run some fine tuning, some experiments, some tests. Keep iterating. Keep testing, and then maybe do some other modifications until I get to some final fine tuned model. Save it to a binary. Hopefully, publish it to a registry, and then kind of disappears, right? Like when is it going to get put into an application or a container, etc. But what we continue to see is that's where things really become a black box, right? Once something gets published to a model registry, if it gets published to a model registry, it's so much harder to understand where did this model come from? This fine-tuned model that we put in our cars that are really good at object detection. How do we know we can trust it? What was the base model? What were the data sets involved? We're sure everything is legally licensed. How do we know it's accurate? And then the last bit, which again, one of those things that's mind blowing to me because we do this for traditional software security, but not really yet for AI security, is that continuous monitoring, right? Just because I've built something and it's fine now doesn't mean it's going to be fine in 6 months or a year. And it's not just based on the performance of it, to your point at runtime, but it might be affected by something upstream that was actually part of the model or the data set there, right? So I always think about the Lion 5B incident from, 4 or 5 years ago now. When you find out that this 5 billion image publicly available data set that was used to train Stable Diffusion, which was, widely used model, has several thousand instances of CSAM, basically child pornography, and you've got to rip it out, right? It's fine. Like your model that's doing image detection might be performing accurately and using it for a use case, but if it's basically has ingrained child pornography knowledge in it, that still poses an existential risk. That's something I need to go rip out, right? And if I don't understand the supply chain as I'm building models, as I'm fine tuning models, I'm going to be completely oblivious to those sorts of risks, even if from a product requirements perspective, my model, my agent is doing what it should 99% of the time. And then 18 months later, all of a sudden, it spits out something very problematic image wise. And now I understand why. It's an extreme example, but it's happened now several times, that specific one. Um,
Yeah, and I just really quickly to interrupt you there, Dan. I would say, the question you asked earlier about, are these risks that need to be controlled for? I think that is a fantastic example, of a third-party vendor might be using this model, which carries regulatory risk for any organization that's using that vendor. And if you're not doing your due diligence and you're not, applying your governance frameworks when you're bringing in these third-party vendors that are using AI, you're at risk of having something happen or ending up on the front page of the news. So it is a very real risk.
yeah. One question we often get is, well, how do I tell whether this model is I can trust or not? This goes back to the question that Daniel asked in chat. And so, when we think about, again, you're using a frontier model, it's more of a question of do you trust Anthropic or OpenAI or Google or Mistral, period. But if I'm just looking at the leaderboard of something like a medical devices or healthcare, whatever benchmarks on Hugging Face, there are a number of policies that we've seen organizations say are important to them, either for security or legal or compliance reasons, right? Where this, like, again, who put this model or data set together is super important. Do you trust it? Is it an organization? Is it a random person? We have some customers that care a lot about the country of origin, especially around data sovereignty laws, right? There are some countries that are much more lax in how data sets are compiled and privacy protections there. So if I just ignore where this data set was put together and I say, hey, I'm just going to use this data set to train my model, I might be violating some US law or European law. Same thing with models, right? There's a lot of companies out there, especially that are close to defense and government, that have, your no DeepSeek, no Chinese models or data sets, whether you agree with that or not. But you need to understand where these things are being put together. We've already talked about, license usage and compliance and, trusted orgs. Another very interesting one, which not everyone thinks about, is kind of the embedded software within model training and development, right? So There have been demonstrated supply chain attacks where if I might load, Transformers or PyTorch or whatever traditional software library in a training or tuning session, that software, it has vulns, can't be exploited. Like I'm bringing someone else's code into my trust environment, touching my models and my data sets. And also, we're seeing this these last two on great display in the open source world for software is maturity. If there's a model that was just published, I might not want to jump on it and bring it in and start fine tuning and training it until the security community has had its time to really rip it apart. We saw this with the first release of GPT-5. Where within a couple weeks the security community and DeepSeek really ripped it apart from a security and privacy perspective. And same thing if a model is too old, right? There's probably something newer, more accurate, etc. So these are some examples, probably not fully comprehensive, but that we've seen of how people can assess risk in open weight models or publicly available data sets. What other sort of policies or aspects of risk, Zach, have you guys seen?
Yeah, so once again, primarily in the runtime domain, you have your standard sort of DLP. You have your standard sort of like, you want to be monitoring your indicators of compromise. I'd say a lot of how agents are working today, it's really around how you're thinking about policy management for the entitlements that you're granting that agent. So what identity is that agent using? What access to systems does it have? And therefore, like what risk do you carry given that access to data or given the access to or given the type of like hallucinated response that might happen. So, a lot of the teams that we're seeing that are doing this the best are using a very similar process to what they've used, which is you sit down, you align on a policy, you go through like a fair review or some type of, like AI responsibility ethics, guardrails type review. But then you pair that with your continuous monitoring and observability along with the discovery of new agents. And that's what allows you to ensure that you are applying these policies and you're governing these things appropriately.
100%. Now let's actually go to the key slide for Daniel's question in the chat around open weight models and mapping, evaluating novel AI security risks. One thing that we're big believers here with at Manifest Cyber, especially on how to approach this stuff, right? At the end of the day, we need to be able to do all of our security operations automatically, right? In an automated fashion. If you are trying to assess risk in an open weight model by manually reading Hugging Face and reading the README and trying to find the license and how it was trained, how it was tuned, and who's this person and where they're based, and let me look at the data sets it was trained on, if they list the data sets. There's a reason why it takes enterprises 6 to 8 weeks just to approve a new open weight model for use internally. That's a lot of time, especially in AI land, when competitors or new models are coming out rapidly and you're losing innovation ground to others. And so behind the scenes we're big proponents of using the bill of materials concept behind the scenes, right? How do we turn model cards, data cards, system cards into structured JSON artifacts so that we can with automation map, evaluate, and manage novel AI security risks, right? So when we talk about open weight risks, to the question in chat, understanding everything from the integrity of the model, right, and looking at the integrity of the weights based off of the parent model, or identifying the parent model and how it's fine-tuned. Again, analyzing who put this model together and how much we trust it. Looking at the license, trying to extract what data sets the model was trained on. We've seen a lot of really popular models that don't actually list what data sets they were used for training or benchmarking or evaluating, which can cause some concern or gap or risk, though there are ways to decide that. Even just understanding how to use this safely or not safely is really difficult and takes a lot of manual work. Another really obvious one, which a lot of people I don't think about, there's a real story from a large healthcare customer that we have that was about to implement an open weight model from Hugging Face that was top of the Hugging Face leaderboard for some sort of healthcare benchmarks. And then after they did the assessment, but before they put the model into production, the model was ripped off of Hugging Face and just disappeared. And that's a big red flag, right, when it comes to trust. And so that's to hopefully answers the question, chat, around some risks around open weight models, but also not just that there are risks, but you need to automate this stuff because otherwise some poor person's going to be reading a bunch of PDFs and websites every day for a long time, and obviously that doesn't scale. So, with about 10 minutes left to go, let's do a quick wrap on some key takeaways. Maybe we can punch out a little bit more on that build time versus runtime recommendation for everybody, and then we can open for some Q&A from the audience here. So, key takeaways we hope everybody leaves with. Most important to assess risk in AI and the AI-enabled software, the software around the AI, before it enters your environment, right? So whether it's from a third party or third party agent, open weight models, a model that you're embedding into your own agents, the best way to reduce enterprise risk before it actually gets into your environment. Second, one thing Zach and I strongly agree on clearly is discovery and inventory are critical, right? You need to understand what's already deployed because that seal has already been broken. Your company, developers and users around your company have already started using AI everywhere. So if you want to put it in the gate for everything net new, awesome. But you got to find out what's already there and how do you make sure that inventory is updated. Next, we do it for software, got to do it for AI, continuous monitoring, right? Just doing that point in time risk assessment when you're first deciding whether or not to use thing is fine, but you also got to make sure it's still working as you would like it and as it should be, 6 months, 12 months, years down the road. And, maybe the answer isn't build time or runtime, but some combination of both, right? If you are building AI into your applications, think about how they're being built in the same way you think about your open source footprint for traditional software. But once you're using or deploying that agent somewhere, you got to make sure that it's still working as you need it, as it should be working. And again, understanding what's in it. So if something goes bump in the night, you know exactly what the blast radius is. Zach, let me bring you in here. Final takeaways, final thoughts here for the audience.
Yeah, and I'd say the thing about this, the takeaways here is that if you've been a software practitioner at any point in time in the last 30 years, this is obvious, or this is not new, right? Like the fact that we've been doing this for traditional software systems for a very long time, I think speaks to the importance of the function. And if you really think about it, like all software development is a governance activity in some way. And I think really with, the advent of digital transformation and some of the new cloud tools and the SaaSification of applications, we saw that bringing governance into the software development lifecycle actually was a way to enable and empower engineers to be better owners of the systems that they were building. It turns out that having great monitoring and great alerting leads to better application development. It turns out that policy enforcement and management of credentials leads to better application development. And so we believe fundamentally that this is true in the AI domain. And if we can bring some of these practices into building AI enabled applications, it not only will make your organization safer, but it will lead to the faster development, more effective, deliverables both internally and externally to customers, and overall just allow your organization to move faster as a result.
100%. All right, we have a couple of questions that were submitted, via chat and got some DMs on this. So I'll read them out loud. And Zach, if you want to take the first swing at them, and we can see where they go from here. So first is what is like the one big or first thing that any company should do to kind of jumpstart their AI governance program? If there's one thing that you would recommend they do, what would it be?
Yeah, absolutely. I think it's the discovery and inventory, like we were talking about. That's by far and away, I think, going to be the highest impact change that an organization can bring. Just start putting that boundary around your organization, and then I'd figuring out what the right policies are, figuring out how you're going to manage that risk, figuring out, how to action, those ungoverned systems. I think falls out of the wash, right? But it starts with you absolutely need to have an understanding of what is in your environment, who is responsible for it, and what are the components that make that thing up? Like how is it coming into your system and what kind of risk are you carrying just by bringing it in?
Yeah, I think my advice would be a little bit different, but going off the last thing you said, which would be if your organization is building AI-enabled applications, especially if they're using open weight models or pre-tuned models, invest time into gating risk automatically up front, right? if you're using Claude, again, it's a little bit separate if you're using frontier models, but getting that speed down of assessing, can we trust this external model data set system faster allows for, reducing more risk up front, but then faster innovation, faster time for the rest of the pipeline. Ultimately, what drives business forward is actually, writing code, writing functionality, and pushing it out. And so you don't want to waste time at the very beginning of the process, and also where the most amount of risk can happen. Awesome. And let's see if we got time for one more. This is an interesting one. If something goes wrong with an AI app or it says here an employee built AI app, but maybe let's just say some sort of AI application, who owns the liability? Like if we're using, Claude code inside of an app and it gives a problematic answer or response that the application then spits out or takes action on. Is it Anthropic? Is it the company who wrote the application? Is it the developer? Who's at fault when there's some issue that happens with an AI enabled app?
Yeah, it's a great question, right? There's that famous quote, I'm probably going to butcher it. This came from like an IBM manual written in the 1970s, which was, you can't ever hold a machine accountable, which is why decision making needs to you can't delegate decision making. A human needs to be making the decision. And I'd say for the most part, I think the way that our current legislation and sort of like case law has progressed, at least in the United States, certainly in Europe, is the company carries the liability. Not the model provider, and I think that's the model providers are bringing tools that then an organization is making a decision to use, and therefore that act of making that decision makes that company liable. Now, I'm sure that there are probably edge cases and very complicated, nuanced conversations that happen in this space, but starting with that in mind and building in defense and layering your observability, layering your supply side, monitoring and inventory, I think is generally going to be, the safest way that you can manage that risk.
Yeah, I don't know if I have anything to add on top of that. I think, yeah, it is hard to blame the machine or the computer. And I think, even as we saw with the airline example, like you can't necessarily blame the model or the provider behind the scene, right? The application still can be responsible for the inputs, the prompts, the handling of those prompts. But I guess it depends on maybe some of the technical details. But it's a really interesting one. I mean, product liability applied to software is still a very fuzzy issue, even in regulatory circles. So hopefully it doesn't take, as always, some sort of catastrophe to force the conversation around, what should happen there. So let's pray that's not the case. We are pretty much up at time, so we will conclude there. Thanks everyone for joining and for spending time talking about this important issue. If you're interested in checking out either platform, either Manifest Cyber, all things software supply chain, AI supply chain on the build time, or Arthur, all things AI governance for runtime for agents across the enterprise, you can scan these QR codes to get free access to the tooling, or reach out to myself and Zach on the socials or other places to continue the conversation. Thanks so much, everyone. Thanks, Zach, for joining us. Pleasure to have you, and we'll talk to everybody soon.
Absolutely. Thanks, Dan. Thanks everybody for joining.